So here in question 4, we're given two molecules and we have IR spectra for each on the next page. The problem is the IR spectra are not labeled, and so we need to come up with a way to determine which one is which. So the easiest way to start in these questions is let's figure out the molecular weight of both of these structures. In order to do that, we're going to need the chemical formulas. So for our first compound, we have C6H12O, and that gives us a molecular weight of 100. Second compound, the ketone, has a chemical formula of C6H12O and a molecular weight of 100. So I'm sure we didn't think it would be as easy as just adding up the molecular weights and looking for them, and it's not. So let's see what happens when we go to the spectra. Well, here's our first one. And the first thing we should notice, we said both of these compounds have molecular weights of 100. But what do we find at 100 here? The answer is nothing. There's no parent peak present at all. Now, does our second spectrum have a parent peak? The second spectrum has a very clear parent peak. And so that's what's going to allow us to distinguish between them. Of these two functional groups, which one often shows a parent peak and which one often loses the parent peak? Well, recall that with alcohols eliminate very easily. They lose water. And so for alcohols, we almost never see the full parent peak. For ketones, while there are some ways that ketones can be eliminated or more accurately fragmented under mass spec conditions, it doesn't happen as readily as it does for alcohols. And so for a ketone, we would expect to see the parent peak. Given that this first spectrum has no parent peak, we can be reasonably certain that that's the alcohol, and that the second spectrum, which does have a clear parent peak, is our ketone.